welcome everybody to the Berkshire Innovation Center. This is the second Catalyst Day for our Stage 2 Accelerator in their second cohort. So this is a day of pairs, I guess, and we'll try to lean into that theme a little bit here, thinking about how founders work with designers, engineers, manufacturers to actually actualize a project. The theme today is going to be about manufacturing strategy. So this is going to be everything from economies of scale, how the volume of your production is going to influence the cost of your units, but also how to pivot and recognize market opportunities or shifts in the market, how to adapt to them, how to design in a resilient way, knowing that those changes do come, and all of the millions of considerations that go into actually making it to market and then succeeding on the market. So I'm joined today virtually by Eric Planey, the CEO of SolarBlock, a company that is making construction materials with embedded solar panels, by David McCloskey from Allegis Engineering, the founder and chief engineer, a contract design and engineering firm out in Somerville, and David Allen, the president of Synecon Plastics, a contract manufacturer doing injection molding and machining, primarily in the aerospace and defense markets. So if each of you can give a sort of 90-second self-introduction, we'll hop into the moderated discussion after that. This talk is going to go until 2 p.m. We'll have a healthy Q&A in the latter half. Then from 2 to 2:30, there's going to be a break in the Catalyst Day. During that break, I'm going to put a few videos up on the screen of the product that's actually in the little case here. So it will be a description of the design process, the iterations they went through, but also how they leaned on different manufacturers to build a pretty well-rounded product. And when we get into that at 2, you're welcome to take the break if you're not as interested in that. But I just wanted to show it as an example of transparency in manufacturing. And one of the things that's so difficult about bringing hardware projects to market is the knowledge silos we run into and how difficult it is to really learn the best ways of making things. So I mostly wanted to share that video, and this product is a little bit of a challenge to that. So without further ado, Eric, would you like to introduce yourself?
Thanks, Tim. Can you hear me okay?
Yep.
Great. First, I want to say thank you to Tim and PJ and Ben and the whole BIC team for accommodating me. I wanted to be up there in person, but unfortunately I had an unexpected change in my travel schedule for later this week, so I'm doing this virtually. It's great to be here. I think most of you in the room has probably known SolarBlock for quite some time. We've been around probably longer than we care to brag about. We are a company that makes a solar embedded concrete wall systems. We first started with what we call a solar masonry unit, a block product similar to the size of a concrete block, and then we embed solar into it. And now we're launching a solar precast unit, which is a precast wall system, which you're seeing more prevalent in construction these days. My background really quick, I'm actually not a startup guru or anything like that. My background has always been in international global banking and economic development. I worked for 2 Japanese banks, mainly out of New York City, but was fortunate to have some international assignments. But I did always focus on clients that were in the automotive, aerospace, defense, industrial space. And then the last part of my banking career was in the energy space. And that's really where I got the hook on all things clean tech and sustainability driven. So live in the Hudson Valley in New York, and SolarBlock obviously is based out of the BIC, and we consider both Massachusetts and New York our home. So it's great to be here, and thanks for having me again.
Thank you, Eric. Really so happy to have you on today's panel. David McCloskey.
Yeah, hi everyone. I'm Dave McCluskey. I'm with Allegis Innovation and Design. We're a product design and engineering firm in Somerville. We started in 2015. Our team's about 7 folks. We're focused on physical products, building things. That all of our projects have a physical aspect to them, but then a lot of them are multidisciplinary. They have power systems, electronics, controls, software, embedded firmware, all kind of layered on top of that. Before starting Allegis, I was a product design engineer at another small firm. Did a lot of appliances, industrial equipment, consumer goods, kind of all over the map, and that kind of carries forward into Allegis. We aren't focused in any one thing, but yeah, we're helping folks in a lot of different industries. We do custom machine design on the really low volume side, 1, 2, 3 of something for automation or test rigs or fixtures or whatever's needed. And then we do a lot of industrial products, kind of B2B stuff, 100 to a couple thousand per year, a lot of sheet metal, machine parts, controls, bigger, kind of higher margin products. And then we do also do some consumer stuff, a lot of international supply chain work on those and manufacturing, but yeah, with the intention of making, 10,000 plus sort of units. So those are each kind of different silos of types of products, and they all have different challenges, and we try and kind of help folks get through prototype and development and iteration, and then carry them into production. But we are not a factory. So yeah, our goal, like a success for us, is to graduate from us into a more contract manufacturing environment.
Great, thank you, David. And David Allen.
I'm David Allen. I'm president and owner of Cinecon Plastics here in town. Started in 1968. I bought it in '89. We had 6 people there. We have 80 now. Primarily a custom injection molder. We build our own tools, but we also have, over the last 5 years, developed some machining capabilities. So we do production machining of metal and plastic parts. We're 50% medical, and the rest is aerospace, military, and I make gazintos. Everything I make goes into something, and so that's my description of what I do. It sits on the table, it's useless. It's a component. It has to be batched with something. And we do everything from prototype, and we try to get involved when someone is just, I've had stuff on napkins, that's still out there. But then, we make, totally make, I think, 20 million parts a year.
Thank you, David. So as we go through, I'll have questions that are pointed towards one or several of you, but this first one's just open. When we think about startups, I think we so often see the Facebooks of the world, these unicorns where in software there's opportunity for infinite scaling, and investors are looking for that thing that's just going to explode because the marginal cost of additional users in the software space is so low. In hardware manufacturing, overnight success can actually really come at the detriment of your business plan. If you think you're going to sell 200 units a quarter and then all of a sudden you have demand for 2,000 and you don't know how to get there, then you have really unhappy would-be customers. So when we think about startups growing in the hardware space and how difficult it is to scale appropriately, I'd just like some kind of thoughts from each of you on how you assess what healthy scaling looks like. So if anyone wants to jump on that first.
Sure,
Okay,
yeah.
go for it.
Yeah, I guess as a design firm, folks come to us at a lot of different stages in their process. Some folks have a napkin. Other folks have been trying to build their prototype for a while, but they can't get past some sort of technical hurdle or manufacturing hurdle or something. But yeah, I think it's good. Like, we try and set realistic expectations. We come across so many folks that are just like, we've built one prototype, we're going to build 1,000 next year, and we're just like, what? Like, that's not the path that we think is going to be best for you or is realistic, right? Like, there's this iterative approach. You've got all these technical and functional challenges to solve a lot of the time. You've got supply chain that you need to establish and vet. And then you've got the final manufacturing stage, wherever that is, whatever that is, quality, testing, agency test. Like, there's so much to it. And so, yeah, if you go to a trade show with a prototype and sell thousands of them and you've only made 2, like, you are in big trouble. And that has happened, and we've worked with folks that have been there, and it's like, hold on, you've got a lot of work to do. And so, yeah, so we try to set realistic expectations and kind of see, like, do folks kind of see what we're saying? And that's not to say you can't move faster, but, when we see someone come to us and tell us they're going to do something like so fast, it's kind of a red flag for us. So we try to just set a cadence and a roadmap for the next 12 to 24 months and say, yeah, like what are the big things, and kind of lay out the milestones to get them through it in an orderly and controlled fashion, because that's kind of what it's going to take, we think.
Could you maybe point to a specific example of where you've advised on a particular design that lets you gracefully scale up that make sense at a lower scale, but if they really hit the targets they have, you could still transition to more mass manufacture?
Yeah, I mean, there's, like, on some of the bigger industrial type products we're working on, not big, but like appliance size. We have a prototype shop and we help our engineers design and build these iterations in our shop. We outsource the metal work, machine parts, plastic parts, controls, whatever. We get all that in and we do the assembly. So we have this kind of closed loop feedback to the engineers. And that goes, a couple rounds usually is required to really get it all working, where like all the boxes are checked off, like it's functionally stable and the manufacturing and assembly process is controlled, and you've taken a lot of the skilled labor out of it, and so you've really got this package that's ready to bring to a manufacturer. We don't want to build 100 of something in our little workshop. We can't. We could build 5, we could build 10, but when they get that order of 100, you really want to have, or 1,000, you really want to have your documentation and your supply chain like so buttoned up and so in control that you can kind of just walk in the door at a factory that's a contract manufacturing that builds these types of things and sit down with their team and kind of have all the answers and be ready to go. And that's kind of the best case scenario, and that's where we try to get folks, right, to really have the documentation like so clean that the factory is like, oh, like our questions are answered and we can give you a quote. We're ready to do this. You've given us what we need. And the opposite of that is, you sit down with the manufacturer and they're like, where are you getting this part? They're like, oh, we got it from this place in the past. We don't want to do it again. You've got all these holes in your story about how you're going to do this. And, then that's kind of, again, just a red flag. Like, okay, we have some work to do to fill in all those gaps.
Thanks for that. Yeah, so really important to have plans for vendor management and clear documentation across the product. Make sure all your goes in its are lined up with backup sourcing. Great.
Yeah.
David, since you have really large customers, sometimes where you're even inheriting a mold where the R&D, the development work has been done, and you're really just dialing in a process and providing a part, versus somebody who does come to you with that napkin, how do you help a company that's at the napkin phase understand what goes into really finalizing a product?
Well, I was trying to think of whether we've actually had someone come in with a napkin that ended up being produced, and I'm not sure I can think of anybody that's done that. But because we make component parts, most of what I do is not a finished product, so there's usually other people involved, and somebody like Dave here or something like that that's put together the package, so we're just a component of that process. For me, a lot of it is, you kind of start out, all right, you want to make this part, it's a great idea, but you're going to need $20,000 for a mold. That kind of, it's a pretty hard stop. You're either ready to do that or you're not. So that helps a lot. And lots of times, we will take someone like that and send them to someone like Dave or other people we know and say, you need to go to them first, because I don't do product development. I don't do product design. I can help and I can suggest things, but in the end, you have to come to me with a print and a model, and you want this material, and I'm going to make it to that, so that I can say I did what you wanted me to do, and I provided you with the product. That he's put, at least those ducks have to be in line.
Sure. So would it be safe to say that if you're using contract engineering and contract manufacturing, you should probably try to keep those separate? You guys found benefits working more with contract manufacturers who do have that in-house design expertise?
Oh, I guess keeping the process separate. Yeah, we work with contract manufacturers, but I was taking some notes earlier and I wrote that down, that contract manufacturing and contract engineering are inherently different, right? Like engineering is, on the prototyping and iteration side is fast, it's changing a lot, it's very fluid. There's a lack of control on purpose, which needs to be carefully managed because it can get away from you. But it's sort of a process and there's a cadence to it. And if you went into contract manufacturing too early or into any manufacturing, like you have to kind of switch gears. And once you're kind of in that manufacturing gear, it's a lot harder and slower and more expensive to go back and start making changes. So you really want to do the design stuff and get it to a certain point, and then kind of have everybody agrees like it's time and you're ready to switch over. And then once you switch over, there are still things that you find and that change and that need work, but you're kind of going at it in a different way now, because manufacturers are all about control and documentation and planning, and it's just a totally different animal. And we've had a lot of contract manufacturers we work with that say they do design work and they have a design team, and we've found, some are good at it, but it tends to be a totally different division of the company. It's not like the guys on the factory floor are also doing product design sometimes. Like, it's a totally different mindset, and it's a different exercise, a different muscle that you need to exercise to do either one effectively.
And in big companies, they will have a new product design department.
Right.
So they do all that work before they give it to the manufacturer. I mean, there's typically a set of engineers and there's a whole unit that's all they think about. And it's not
Yeah.
mushed together.
So if we take this design for manufacturer discipline, Eric, maybe you could speak to how this influences your scaling strategy, trying to figure out what market exists and how best to reach it.
Yeah, so what comes to mind when you ask the original question, Tim, are three words: market-driven constraints. And so when you're a startup, now we are in both climate technology and a subset called construction technology. I think there's several constraints that we needed to have identified early on in the process of scaling our company. The first of which is we're making a product that's still going to generate solar power. And so we're not any dissimilar than, say, a rooftop application or a solar farm out there. We need to show a payback period for the cost of putting our product on a building in a very similar way that a solar farm would. So that payback period has to be driven by what the market dictates for other ways of generating green power, which is roughly about a 6 to 7 year payback period. So from there, then you kind of have to back into your cost. How much is it going to cost to make and sell one of our individual block products? And we'll use block as an example for now. What we started experiencing was, when I first joined the company, we were going to in-house the complete manufacturing of our product. So the solar panel, because it's a unique size that fits in a cement block, we had the unique IP associated with it. We were going to do all the soldering, all the work, all the secret sauce work between the actual solar PV and the block itself, all the connectivity, et cetera. Well, when you started adding up with a lot of our prototyping contract manufacturers were doing for us, the quotes and estimates we were getting were going to make that product so expensive that I don't think we would have been able to sell any. So I had the good benefit of bringing on an entrepreneur in residence who had great experience scaling solar companies in the past. And the very first thing he said to me was, there is no way you should actually be making your solar module yourself. There are global providers of solar panels and solar modules that can do it faster, better, cheaper. And especially what happened last Tuesday with the election, climate tech companies have to understand that there's going to be less and less opportunity to sell a product that's going to have a green premium associated with it. It has to be ROI driven for the customer. So we changed our business model on our block product so that we were going to outsource the solar module manufacturer. We found an incredible company based out of Oregon with an operation in Ohio called Sunwise. And they had access to Asian manufacturers to make our solar model much, much cheaper. So they're actually in process of onshoring manufacturing capabilities for that. And then, secondly, I guess that was really the main point I want to get, is just be more market driven in that. But also in the world of climate tech right now, especially as you're going for venture capital money, everyone hears those big stories about the big VC raises, a Series B that raises $700 million for a company. But the reality is the VC markets are not doing well. In climate tech specifically, deployments of capital are down 41% between Q2 and Q3 and 27% for the year. And there's a lot of climate tech VCs that are still afraid of hardware. When I did my first launch of our VC raise last fall, I reached out to about 75 climate VCs. I couldn't believe how many times I had people come back to me and say, oh, you know what, sorry, we're in climate tech, but we're only doing software. And I kept thinking to myself, how is software going to decarbonize our planet? We have to make things in order to solve for climate. So the lower you can bring your upfront capital expenditures, your property, plant, and equipment, by doing things like smartly outsourcing your contract manufacturing, as you scale up, the better you have chances of actually landing that VC investment. If you show you've got a control on your upfront costs, then you're going to be a little bit ahead of some of your competition that's vying for that same VC dollar.
Thanks, Eric. So yeah, definitely still managing your vendors, understanding those costs. I think it's really interesting, you know, as you mentioned, being really cost driven in your product here. You had to recognize where your actual value was with SolarBlock. You're not inventing solar panels. You're not even producing the PV panels yourself, but you really understand construction materials and the construction industry, where those economics fall. So what was that process like, kind of understanding that there needed to be a little shift in how you posit the product on the market?
Yeah, it's a great question because our world, we are in a world called BIPV, Building Integrated PV, which really is another way of saying vertical solar. BIPV actually had a negative reputation for some time because over the course of 12 months in most latitudes in the United States, BIPV puts out less solar output than a rooftop system. So if you go back 7-10 years, when the cost of solar panels were approaching $1 a watt or above $1 a watt, the economics of BIPV didn't make sense. Right now, solar panels, because there's so much capacity globally, some solar panels are wholesaling for 10 cents a watt. So even your BIPV proposition is a more positive ROI proposition. So that's the first thing. We had to really understand BIPV. Secondly, and one thing that I encourage people, go on solarblock.com, applications, and look at our test wall. What's really cool is we're actually proving our investment thesis right now, which is our solar walls actually put out more output in the off season. So a rooftop system obviously peaks in the summertime because of the sun intensity. But in the fall through spring, when the sun is lower to the horizon, that's why we have evenings that get darker earlier, that sun is actually shining brighter on a wall system. So if you have a building that has a rooftop system and our system, then you have a smoother curve of output during the course of 12 months. That has become also more important because in states like Mass and New York, where everyone is trying to electrify their buildings for heat generation, then having consistent electricity in the winter months is generated from green sources is important. So we had to identify really how our product fits into the greater scheme of building materials and net zero buildings. And I don't think we did a really good job of that early on, and now I feel like we're doing a very good job of that. And then also we just had to stay on top of trends. And one thing we started noticing when we were talking to customers, particularly contractors, early about a year ago, everyone said, well, we're not building as many buildings with blocks these days because there's a massive labor shortage. So as a result of that, we started investigating what's called precast, which is a concrete wall panel that's actually made in a factory and hoisted on site. So instead of having a myriad of bricklayers, you have several bricklayers or steel and construction workers hoisting a wall panel on site. So pivoting and adapting and understanding your market is something that is so essential. Just because you're locked in with one product doesn't mean that the market doesn't evolve away from that. So we still think we're going to have both products, but precast is definitely the future, and the block product's going to be bespoke. So I don't know if that answers your original question, Tim, but it's really just staying on top of and thinking 2 steps ahead of where the market is and where your cost structure is, and that's going to help. And I'm starting to feel very positive about what we're going to be doing in terms of our VC raise here in the coming weeks.
Thanks, Eric. Yeah, it's a good reminder that the customer is always right. It isn't about appeasing Karen at the cash register. It's about understanding that the market dictates where money is ultimately going to flow, and you have to be responsive to that. So we see founders with passion, creativity, who want to do a lot of things and sometimes do a lot of things at once. Dave, when you have a founder come to Algus for help in designing, how do you help them understand where their value in an innovation really lies?
A lot of times they bring that info to us, right? Like they're a lot of the time specialists in something. They've developed a new technology or a material or something, and they know that market and that industry, and they see an opportunity for it. And we don't advise them too much on that. They tell it to us, and we hope it makes sense because we're trying to build something that they're asking us to build that usually encapsulates and applies their technology to some sort of useful state. But yeah, I don't think we're telling them like whether or not their business should exist. I think we're kind of checking again for like, is the story they're telling us makes sense, right? If they're bringing us a description of some sort of product they want to build that is going to cost X, and then they're telling us someday it's going to cost Y, and we're like, that's a long way off. And let's keep this in mind as we go here. Like, so we started advising them, I guess, on features and manufacturing approaches that are going to help them get to the manufactured cost that they say they need to make their business model work.
So the assigned value or expected value is really always going to be in the domain of the founder, but you focus on real world costs, what you can do to reduce
They tell
them.
us, like, okay, like, our business model is built around this product manufactured for this price and sold for this margin, and then we and that's never where we are. We, very rarely are they able to achieve that. And so it's like, okay, what's the path to get there? Have you sold some units? Do we need to deliver those? How many? How soon? What margin's acceptable on those? Because it's probably not your final margin. And I think keeping the margin in the front of the view is important as they go, right? A lot of folks lose and they're like, oh, we'll get back to that someday. I'm like, this is really important. Like, this is not a someday thing all the time. Like, sure, if you want to build one prototype to test something and it costs too much, that's fine if you're learning. But as soon as you decide, like, okay, this is our product, this is the format of it and the architecture of it, and this is how we're going to manufacture it, the cost has to be right there. It has to be something you start working on, because it takes a while, again, to build these supply chains and test them and vet them and get all the parts in and kind of go through that process. And so, cost reduction is not always something you should leave to the end. It's something you need to at least keep revisiting along the way and keep in control. Because it's quite challenging.
And when you go through that journey with them, do you help them see that this feature is 10% of your cost, this feature is 60% of your cost? Do you really value them in that proportion?
Yeah, it's all about compromise, right? And goals and balance. Sure, they've got a long list of features and they'd love to have all of them, and sometimes they can and sometimes they can't. And it always comes down to money, right? These are all businesses people are trying to start, and so they have to make compromises and concessions along the way as they start to get more and more real information about what it's going to cost. Because at the beginning, everyone has a kind of cloudy picture of, like, how much this is really going to cost. The design's not really frozen, the supply chain's not really in place, and so nobody really knows how much it's going to cost, and we all are speculating, like, we think we can get it down here. But as you get further along, you're like, all right, our sheet metal costs that much, these sensors cost that much, it's got a fan in it that costs that much. Like, you get the real numbers, and you start to get the reality check, like, okay, maybe I can't have all these sensors that I want. I got to start weeding some out, or I got to find cheaper ones or buy them from somewhere else. And so there's a lot of legwork, working directly with manufacturers in Asia to try and source components that, maybe they're not the German one you started with, or the American-made one that you wish you could have, but it's, for certain types of businesses and products, it's, you just have to make these compromises and try and get there, because the cost is often very important.
And that process is not just for little companies. I mean, one of our biggest customers, Siemens Healthineers, put a product out, and some guy way at the top had a deadline, and they needed to introduce it, but almost instantly, they were coming back around and say, we got to pull costs out, because they did things for speed to get the product out, and now they can't sell it for what it's costing them. And so then they go, and to go back through and make changes in and of itself is costly, because you have your whole design, you've come up with everything, and now you're going back and you're trying to change this or make 3 parts into 1 part or whatever they do. So it's better to spend that time up front and really understand that and work at that. And the more complicated your product is, or the more components it has, the harder that process will be, but the payoff will be more significant down the road when you've gone through all that. And it's painful for these big companies. I mean, so.
And when you have one of those big customers who's been working with you for a while and they want to make a last minute change, it's very difficult for them to move to a different contract manufacturer at that point. So the negotiation is really between you and them and what you can help them to do to reduce costs. But they have few options if they wait that long to make changes.
Yes, which is kind of a nice position to be in. You can't abuse it, but And typically, they're not looking to go radically different. They're just tweaking something or thinking of it a little bit differently. And half the time, if they talked to us at the beginning, we would have told them that was a dumb idea and you should do it this way, but they don't listen very well.
So they don't listen well. I think that's something that I've heard from both sides of the table as long as I've been here at the BIC, that it's hard to get straight answers from manufacturers. It's hard to get straight answers from founders. And I think a lot of it is just, chalk it up to poor communication. But some of it is that some people view it as sort of an antagonistic relationship and that you're kind of competing with each other. How little do I have to pay you for this thing? How much can I get from you for this thing? How do you feel about that relationship? How do you turn that into a positive, collaborative one?
Can I jump in on this one?
Yeah, please, Eric.
There's two things. First, the one analogy I was going to make is, a lot of founders that are starting out now that are young enough to not know the history of even Tesla. Tesla's very first car wasn't made completely in-house. It was a chassis from Lotus wired with 1,000 laptop batteries to make a little two-seat roadster that was used as a proof of concept. You outsourced the manufacturing of the chassis. The chassis was already, safety certified by most, countries' transportation safety administrations. Boom! All of a sudden, you're making a car. It's generating revenue, and then you go get your venture capital money, your U.S. government loans to actually make your own proprietary model. It is not a bad way to go at all. Let somebody else who has that capability do that manufacturing. But going to your question just now, when we signed an MOU with Sunwise Corporation to be our outsourced manufacturer of a solar module, there was zero antagonistic relationship, and maybe we were very fortunate. But I just felt they brought so much to the table in terms of their skill sets and their capabilities. They're a group that, the CEO is an engineer. Their whole team are really engineers that just know how to make things, and they get excited by it. So there's definitely, of course, when it comes to like negotiating those first 1,000 units, if you will, you may not be totally happy with the pricing they're going to charge. But if you want to get the quality and you want to have the reliability, then it's still a lot cheaper to have a little bit of a higher variable cost on a per unit basis than it is to have all this fixed cost with trying to do everything in-house yourself and having to worry about quality control when you've got somebody that's already gone down that road. So I don't think it has to be an antagonistic relationship at all if you find the right partner. Now, secondly, we just signed an MOU several months ago with a precast manufacturer in north of Saratoga, New York, named Fort Miller. One of my favorite things about Fort Miller is they're an ESOP, which means they're employee owned. So everybody brings a proactive, open mind mentality to the table when they talk to us about prototyping our first product for our precast unit. So I would say it doesn't have to be antagonistic. It can definitely be cooperative. You just have to be sure to make sure that you have the attitude that you're going to take care of your partner in this process. And then if they have the same reciprocating attitude, good things can really come from that.